In this last example, we're going to look at a more complicated trig applications question. Midnight depth d feet of water in a harbour 2 hours after midnight can be approximated by the function below. So we've got d of t equals 35 plus 15 cos of a half t, where t is between 0 and 24. There's no degrees symbol here, so we have to assume we're working in radians. So part A of the question, a ship with a draft of 25 feet is in harbour at midnight. By what time must it leave to prevent grounding? So the draft part of the ship is this bottom bit. So if the water goes below 25 feet, then the boat's going to be in trouble. So the first thing we have to think about is, what is this graph going to look like? 15 cos a half t plus 35 if you like, so it's the cosine wave. It goes an amplitude of 15 and down to minus 15, it's been shifted up 35, and then we've got this 25 feet. So here's your cosine wave, and we have 25 going straight across. It would be a straight line because it never changes. The draft of the ship is constant, so straight line at 25. So what happens is the water will dip below 25, and then it will come up higher than 25, and then dip below 25, and then come up higher than 25. What we're trying to find is this value here, because the boat's okay at this point, and it's okay here, but as soon as the water dips below 25, the boat's in trouble. So it says, by what time must it leave? Well, it must leave by that yellow dot. So if we can work out what that yellow dot is, then we can answer the question. And to do that, we just need to solve this equation. So the first thing we want to look at is the domain between 0 and 24, but we're dealing with 0.5t here. So we can change that to between 0 and 12. So we're looking for values between 0 and 12. So we have our formula. First thing, we need to let the height, or d of t, equal 25 feet. So 25 equals 35 plus 15 cos a half t. Rearrange it as before, so subtract 35, then divide by 15. Now, because we're in radians, at this point you should have your calculator in radians. Just change the mode from degrees into radians. You should already know how to do that, and if you don't, then obviously go and ask your teacher or ask myself. So when you inverse cos this in radians, do the same thing. You should be using the positive value to find your acute angle. So your acute angle, or your base angle, inverse cos this, and it comes to 0.84 radians. Now, what coordinates are we in? Well, the cos is negative, so when the cos is negative, we're in the sine quadrant and the tan quadrant. Now, because we're dealing in radians here, this doesn't make as much sense. The 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360. What we should know though is that 180 degrees is equal to 3.14 radians, because it's pi. 180 degrees is pi radians, so that's equal to 3.14. So if we want to go into the sine quadrant, the second quadrant if you like, instead of going back from 180, because we're in radians, we go back from 3.14. And to get into the tan quadrant, we go forwards from 3.14 by 0.84. So 0.5t equals 3.14 take away 0.84, or 3.14 plus. So that comes to 2.3 and 3.98. To get t, we have to double this value, so that comes to 4.6 hours, and the other value comes to 7.96. But back to the start, and looking at the question, by what time must it leave to prevent grounding? What we've done here is we've found these first two values here, but we're only really looking for the first one. So we don't really need the second value here, which is this. We only really want the first one. Now 4.6 hours, really what we need to do is get that into hours and minutes. And to get 4.6 hours into hours and minutes, you take 0.6 and multiply it by 60 to get you into minutes. So that works out as 4 hours and 36 minutes. So everything is to do with midnight in the question. A ship with a draft of 25 feet is in a harbour at midnight. What time must it leave? Well, 4 hours and 36 minutes after midnight. So that's 4:36. On a wee diagram, that first bit would be 4:36 or 0436 in the 24-hour clock. And the second question, what is the next time it can return to the harbour? Well, looking at this wee graph here, it can return when the level goes above 25. So that's this next value here, and we've worked that out, 7.96 hours. Use the same process, 0.96 hours times 60, and that'll get you that in minutes. And that works out as 7 hours and 58 minutes, so that's 7 hours 58 minutes after midnight, which is just 7:58 or 0758 in 24-hour time.